As we continue the design of our collet receiver, there's things we need to be aware of. One we've already discussed is the thickness of this plate is very critical for the positioning this way of our part because it affects if the drill bushing's on the correct location. But the other thing that's critical is from this edge of the plate down to the center is a critical dimension because our indexing pin is derived from that height down. So we have to think about this when we continue our design. So I'm going to Control Tab to the open receiver ring, and we're going to have to look at a couple of things. As one, this will need to be a part that can be hardened. It's going to be subject to a lot of movement over the years of the use of this jig as we tighten and untighten for every indexing and loading parts in and out. It will definitely need to be cylindrical ground or precision ground on a jig grinder in order to function as designed. But let's just look at what features are really critical. The 15 degrees is reasonably critical, as well as the diameter here where the collet receives. But first, this dimension is critical because it's the one that's going to control where that bushing is, because the rest button is pushed into it. So what type of tolerance can we have on this 1/2 inch dimension? Well, as we saw earlier, we have 4 thou of tolerance left. So I'm going to give 2 thou of tolerance to this feature. So I'm going to come over here and tell it's a limit dimension, and I'm going to add -2 thou and say OK. And then I have 2 thou left for the hole in the other part. So next, as we just discussed, its center height or location within the jig itself is very critical because it will affect the indexing pin. Either this diameter or this diameter must be tightly controlled. In this case, I'm going to tightly control this diameter. So I need to find that, and if it's not dimensioned here in the part for creation, I'll need to tightly control it in the drawing when I dimension that diameter. To add the control now, I'm going to go back and I'm going to edit my sketch used to create it. I'll look normal too. And it was dimensioned here. So that isn't the dimension I want because I want to be able to control this a lot tighter. So I'm just going to delete this dimension. I'll activate Smart Dimension and I'll redimension it to the center line because it's the diameter there I need to tightly control. I'll say OK, and then I'll come over here, and here's where I'll set the precision or the control of this dimension. Before we determine the actual tolerance for this 4-inch dimension, we should talk a bit about how I arrived at it. Well, first, this part is the receiver for the collet. So I'm limited by the part diameter, which is 2 inches, and then I had to think about the wall thickness of the collet, and we'll come back and we'll discuss that as well. And then I think about the wall thickness of this part. I don't want a really thin wall thickness that's going to give me issue during heat treatment with cracking or too much twisting. That's why I had a 1/2 inch. But then I've gone back and changed this to 4-inch. And I selected the 4-inch because it's from our chart of standard preferred sizes in inch. And as much as possible, we should work with standard preferred sizes as it cuts down the cost of the part. Now that I've chosen a preferred size for my feature, the next thing I need to think about is what tolerance I want for it. And the tolerance is based on its function. I would like as minimal positional error here as possible and a light press fit. So I go to the IT tolerance grade chart as shown here. I find 4 inches. And the first thing I say, okay, for a 4-inch fit, if I do an IT4 tolerance grade, how can that be machined? Well, lapping and honing. And remember, the smaller the tolerance grade, the more expensive the part. If I select an IT tolerance grade of 5, the part can be made through cylindrical grinding, which is significantly cheaper than lapping and honing because that would be done after the grinding. So I'm going to go with an IT tolerance of grade 5. This means my minimum feature size will be 4.0000 and my maximum feature size will be 4.0006. At this point in time, we should be aware I've chosen the tightest tolerance possible for cylindrical grinding, which again keeps the cost up. When we go to make the mating hole in the next part, we might reconsider and change this to a looser fit such as the IT6. My main concern when designing this part's feature size is I want a light press fit, a press fit that won't cause distortion when put together, but won't use up any of my positional tolerance. For now, I'm going to go ahead and add that tolerance to my feature, and then in the next video, we'll continue our examination of this part.